All right, guys, this is Packet 4, Lab 1, and we're learning about rational exponents. And rational numbers can be written as fractions. So when you see the word rational and as an adjective, it usually means that there are fractions involved. Fractions. Okay. So it says at the beginning we learned about positive integer exponents, but now we're going to talk about negative exponents, which we did yesterday in our Wednesday, Virtual Wednesday. And we're also going to look at fractional exponents, okay? All right, so this first part, this is just a review of other exponent laws that we've learned. Okay, zero exponents, that's just something different. Anything to the 0 power is 1. And negative exponents, when something's taken to a negative power, there's no negative value involved. It just represents that the x to the negative b is really 1 over x to the positive b value. All right, so basically, when we have rational exponents, okay, such as this is saying the base b is to the m over n power, this fractional exponent. Let me write that a little clearer, okay? So I have my base b written to the m over n power, and it can be written as a root, okay? And these two roots are equivalent. All right, so maybe you're wondering why we have this like flower power thing over here. I'm just going to talk about that real quick. All right, so if I have a fraction bar, okay, this is going to be my fraction bar. Okay, this fraction bar is going to be kind of the same as this. Okay, and if I draw a little flower pot here, and below the bar would be the roots. Okay, so the root is, I'm just going to say root singular, is below the fraction bar, and on top is the flower, which rhymes with power. So on the top is the power, and to remember it's the power, we know it rhymes with flower, so that's where the mnemonic device flower power comes from. All right, so when we have a rational exponent, the top of this exponent, the numerator, right, represents the power, just like the flower from the flower pot, and the denominator represents the root. Okay, so if I were to write this, and they have it written out for you above in root form, b is the base. Okay, that's basically the radicand, the number underneath the radical sign. The power is m. Okay, so that base is raised to the m power, and the root number goes here. Okay, so in this fashion, it would look like the exponent maybe would be done first and then the root, and the order really doesn't matter. We could actually do the root first, the root of b, and then take that to the m power. So basically this is just saying the order doesn't matter, okay? So the order doesn't matter. And sometimes it's easier to do the root first and then the power. And other times it's easier to do the power and then the root. And we'll discuss that when we do some examples. All right, so before we move on, I want to just write about one example you should always know of, okay? So if you see x to the 1/2, we're just going to talk about this a little bit, okay? Again, here's a rational or fractional exponent. I'm going to write it in root form. So the radicand or the base or the radicand is x. All right, I have my power of 1 and my root is 2. Well, if you remember, if I have a square root, right, a square root, the root is actually 2. We don't have to put a 2 in there. If there's no number in there, the root is 2, okay? So, and the power is 1, right? So basically, x to the 1/2 is just the same thing as the square root of x. All right. So, and again, x to the 1/3, these are just some of the more simple ones with a power of 1. Okay. Again, the power on top is 1 and the root is 3. So x to the 1/3 is just the cubed root of x, and so on. Make that look more like a 3. All right, so we're going to be working with rational exponents. Okay, so exercise 1 says rewrite each of the roots using roots instead of fractional exponents. And again, roots is not only limited to square roots, but we can have square roots. That's the lowest one, right? We can't have like a unit for a root. The lowest one is a 2 in the root there. So a square root, which is the same as just without a number, right? That's equal to a square root. Or you can have a cubed root. Okay. Okay, so these root numbers, this root number could be anything. All right, so, and it says to use these without the calculator. So we're going to practice these without the calculator. Same thing on the homework. You can check with your calculator, but I want you to get used to doing these without the calculator. All right, so we're going to write them as roots. So here we have 16 as our radicand or our base, and the power is 3, and the root is 4. Okay, so basically this is saying the 4th root of 16 to the 3rd power. All right, so, and this is where that order comes in handy, where you can either do the 4th root of 16 to the 3rd power, or we could do 16 to the 3rd and then do the 4th root of it. Well, a lot of us probably don't know 16 to the 3rd power in our head, but maybe you do know the 4th root of 16. Okay, what times itself 4 times would be 16, and that's 2. So 2 to the 3rd power is 8. Okay, and if you did know 16 to the 3rd power and took the cube or the 4th root, you'd also get 8. So in this case, the final answer is 8. All right, next one. We have 25, which is going to go underneath our root symbol. Okay, the power is 3 and the root is 2. So again, in this case, we're going to want to do the root first. And again, if the root is 2, we don't have to put the 2 in there, okay? And since I'm going to do the square root first and then cube it, because that's, again, it's probably easier in this case, instead of doing 25 times 25, which is 625, and then multiplying that by 25 and taking the square root, we can just do the square root of 25, which is 5, and then we can figure out 5 to the 3rd power, which is a little easier, okay? So 5 times 5 times 5 equals 125, so this one equals 125. All right, next one. Okay, this one's a little trickier because it's not only in fractional form, but we have that negative. So remember, as soon as I see that negative as an exponent, I'm just going to rewrite this as 1 over 8 to the positive 2/3. All right, so that, sorry about that. And I don't want to stop here. I'm going to put it in root form. So it's 1 over, okay, so 8, the power is 2, and the root is 3. Okay, so in this case, you could equally, probably either way is, the difficulty level is about the same. If you do it, when you do 8 squared first, okay, it would be the cubed root of 8 squared is 64, and maybe you know the cubed root of 64 is 4, to get 1/4 is your final answer. Or, okay, maybe a little easier, you can do the cubed root of 8 first, and then square it. So this would give us the cubed root of 8 is 2, and then 2 squared is 1/4. So like I said, the order doesn't matter. You can either do the root first or the power first. Okay, moving right along. This says rewrite each expression in the form a b to the x, where a and b are both rational numbers. So basically, this is just going to be our lead coefficient. Okay, we're used to a being our lead coefficient out front. All right. I don't know why coefficient looked weird to me in that other video I did, but it was spelled right after all. And b is just an exponent, and since it can be rational, that means that b could be a fraction, and most likely it's going to be, since we're talking about rational exponents. All right, so for part A, this is just 5 times, okay? And then instead of the square root of x, we're going to write it as a fraction. So again, the power, which is 1, which is not showing because when we have a power of 1, we don't have to write it. And the root in this case is 2. Again, when there's no root number indicated, we know it's a square root, so a root of 2. So we would just write this one as 5x to the 1/2. Okay, so this and this are equivalent expressions. So that's all they want you to do is reverse it. We're basically doing the other direction. Okay, so for this one, we could, just change this numerator first into the x with a rational exponent. So the power is 1, the root is 5, and this is over 4. But they don't want it as a fraction, so instead of writing that, we could just, we know there's a 1 out front, we could just say it's 1/4, okay? Because 1/4 is a rational number, x, and then to the 1/5. So now it's in the form that they asked us for. And I'm just going to rewrite that a little neater. Sometimes I need to remember to zoom in more so my handwriting is a little more legible. There we go, that looks better. All right, C. Okay, this one, hopefully you're saying, okay, this part's in the denominator, so I'm going to have a deal with a negative exponent here in a minute, but first I'm going to change this part into a fractional exponent. So the power is 1, the root is 3, and if I want to bring it back up to the numerator, I just have to say, okay, that's the same as 7 times x to the negative 1/3. Okay, and that would be my answer for this one. All right, this one, again, since the root's in the denominator, we're going to end up with a negative exponent. So this would be the same as, we have 5 over 3 times x, and then our fraction is our power over our root. All right, so we want to move this up to the top. We can just keep 5/3 out front as our coefficient, and this will be x to the negative 1/10. All right, so hopefully this is making sense to you. Getting used to converting from root form to rational exponent form and vice versa. All right, exercise 4, rewrite each, this is not multiple choice, of the following as a rational exponent in simplest form. All right, so we take our radicand, we make it a base, and we're looking at power over root, okay? So I'm just going to reiterate that. I know maybe I should have been doing this all along just to show you. Okay, we think flower power. So in this case, our power is 7. And remember, if there's no root there, the root is 2. So this is the same as x to the 7/2. Now, maybe you're thinking, well, wait, we've reduced x the square root of x to the 7th earlier this year. Okay, so hopefully you actually remember that. And when we have the square root of x to the 7th, remember we changed it to something like x to the 6th times x. And then what we could do is take x to the 6th out because it's a perfect square. So that would give us x to the 3rd times x, okay? Times the square root of x, I should say. All right. So hopefully you're following this procedure. This is what we did earlier in the year. And if you look at this, now that we know we have x to the 3rd times the square root of x, we said was the same as x, the power is 1 and the root is 2, so it'd be x to the 1/2. And then when we multiply, we add exponents. So this would give us x to the 3.5. And if we write that as an improper fraction, sure enough, we get x to the 7/2. So it's just another way to manipulate exponents. All right, so for this one, x equal, or not x equals, x is going to be my base, and then I'm going to have power over root. So this would be x to the 6/4. And I wouldn't leave it like that. Just like any fraction, if it can be reduced, I should reduce it. So this reduces to x to the 3/2. And likewise, we could actually do the same thing here. Since it's a 4th root and there's at least a power of 4, we could simplify it and confirm that this is also equal to x to the 3/2 if we do it another way. But in this case, we want the base to a fractional exponent. All right, so for this one, first we're going to change what's in parentheses as a fractional exponent. So we have our x, and then we have the power of the root. So we have x to the 1/2, and then we take it to the 6th power. So we get to use our exponent rules. When we have a power to a power, we multiply. So this would be x equals x, and then 1/2 times 6 would be 3. So this turns out to be x to the 3rd. And again, this one, you might see it as well. If we have the square root of x to the 6th, if you did the square root of x times itself 6 times, right? For every pair, that would just turn into a regular x. So if we had 6 of them, you'd see that'd be x times x times x, which is x to the 3rd. Everything makes sense. Sorry, that doesn't look like an x there. I was trying to be fast and I was getting sloppy. All right. Next. All right, so when the 10 is outside, remember this is the same as the cubed root of x to the 10th. Okay, there's only one item under here. So we can do this. Remember I said the order didn't matter for root or power. But either way, it's x to the power over root. So this is just simply x to the 10/3, written as a rational expression. All right, so from this point forward, we have just multiple choice questions now. So we're going to finish the next few pages, and then I'll show you what you're going to do for homework. Okay, so exercise 5, this looks kind of, maybe it looks kind of intimidating, but it just gives us a function, and they want us to input a +4 in for x for the function, and we're going to do it without the use of our calculator, and we're going to show our steps. So maybe it looks complicated, but it's not so bad after all. Okay, we just need to get started and chip away at it. So we have 10 times 4 to the 3/2 minus 24 times 4 to the -1. All right, so if I'm following order of operations, which I need to do, it's 10 times 4. There's multiplication, there's exponents, there's subtraction, there's multiplication, and then exponents. So I know that I need to take care of the exponents first. Okay, so these are the two things I'm going to simplify first. All right, so I have 10. I'm just going to bring down the 10 times, and then I'm going to rewrite 4 to the 3/2 as a root because it's easier for me to calculate that way. Okay, so 4, my power is 3, and the root is 2. And remember, I came across this exact problem earlier. 4 to the third power, oh no, it was similar to this. 4 to the third power is actually 64, and the square root of 64 is 8. Or I can look at it as the square root of 4 is 2, and 2 to the third is 8. So any way you choose to do that, 4 to the 3 halves is going to be 8. All right, so this is 10 times 8, which I'm just going to go ahead and put 80 because this is separated by subtraction. So basically, after we do the exponents, we're going to multiply and then subtract. So that's okay. All right, on this side, it's going to be 24. And 4 to the negative 1, okay, I don't have to change this to a root, right? Because 4 to the negative 1 just means 1 over 4 to the positive 1, which is just 1/4. And then 1/4 of 24 is the same thing as 24 divided by 4. So that's just 6, and we get 80 minus 6, which is 74. All right. And again, once you substitute the 4, you could just type all this into the calculator. Since it's all numeric, it's going to give you the same answer, but you should be showing some work. All right, exercise 6, which one's not equivalent to x to the negative 7/3? Okay, well, I know x to the negative 7/3 is the same as 1 over x to the 7/3. And I know this can be rewritten as a root instead of a rational exponent. So I have x, my power is 7, and my root is 3. So let's check this out. Well, this number 3 is identical, so that is equivalent. I'm looking for the one that's not equivalent. 1 over x to the 7/3. I didn't realize that was on there. That was my first step I did. And then between 2 and 4, well, I can't just switch the root and the power. Okay, so this is looking like my answer. But maybe you're confused by this. Okay, so if the whole thing is a cubed root, this whole fraction, what I could do is I could say, okay, I can separate that and do the cubed root of 1 and then the cubed root of x to the 7th on the bottom. And since any root of 1 is just 1, that cubed root of 1 just turns into 1, which is equivalent to 1 and 3. So 2, I'm confident that my answer is 2. Okay, I didn't put the numbers here. Maybe some people were triggered by that. I should go back and do that. That was my first multiple choice. Okay. Oh, I think I said they're all, actually, we're going to skip these. We're going to go back to these. Don't cross them out. We're going to skip these, and we're going to go back to these, I believe, in the next lesson. So skip 7 and 8. And for exercise 9, we're going to rewrite these in radical form. And I'm just going to do the top half. I think it's kind of overkill to do all of these. Oh, they're very similar. It's just reciprocals. Okay, so these 4 will be enough. Now, basically, the difference between A and B are the parentheses, and the parentheses do make a big difference. All right, so if I'm going to write these in radical form, in this case, the 4A, the whole thing goes underneath the radical because it's in the parentheses. Okay, and the power is C. All right, so in this case, if I write the power of C and it has to go with all that, I want to put parentheses around it still. I need the parentheses there. The power is C and the root is 3. Okay, the other way to write this, all right, is the root is C, the base is 4A. If you put the C outside of here like this, that's the only way you can get rid of not putting the parentheses. If the C, well, I guess you still have parentheses, but the parentheses now enclose the whole radical. But hopefully you see that C goes with this whole thing in both cases. All right. So if you're going to write it the way I did on top, you have to have the parentheses. Otherwise, it would look like the exponent C would only go with the A. All right. And the differences between A and B is B really means 4 times A to the C to the, or C divided by 3 power. So this one would be 4, and then we'd only do the A would be the radicand of our radical. So we have 4, and then A, the power is C, and the root is 3. So those are different, okay? Based on the parentheses, you're going to get different answers, so just be careful with that. All right, and basically C and D are the same thing. So if 5x is in parentheses, that whole 5x needs to be underneath the radical. The power is B, okay? So to indicate the power goes with the whole thing, I either need to put this in whole radical in parentheses, or I need to put the 5x itself in parentheses. Okay, so say the power is B and the root is 4. That's one way to do it. Or I can just do it like this and put the B underneath that as well. These are the same thing. Okay, but I need some form of parentheses there. In this case, there are no parentheses, so it's just 5 times x to the b over 4 power. So I really don't need parentheses since there's only one item that's part of my base. All right, I can put the b underneath the radical. I can put the b outside my radical as the power, and my root goes here. Either way is acceptable, so I'll just write it both ways. And usually you see parentheses there. You don't really need them though, I guess. I guess I can just do that. Same thing. Okay. All right, so those were the notes. Okay, those were the notes for the lesson. You do have homework that goes along with that. All right, and the homework is pages 5, 6, and 7. I know that sounds like a lot, so you're going to skip page 4. We're going to do that in a different lesson, so don't just cross it off. And this is page 5. Okay, so the homework is pages 5 through 7. All. Okay, most of it's multiple choice. Guys, these should be super fast. This is the ones like 1 and 2 that are not multiple choice. It's to build fluency with these. Okay, so hopefully you can look at, I'll just do E with you real quick. 625 is the 4th root of 625. I know it says to do as much as you can without the calculator, but maybe you realize that the square root of 625 is 25. You may or may not. And then the square root of that again, because the 4th root is basically the square root of the square root. So this would be 5 in this case. I guess that was probably one of the harder ones to do in your head. Oh, I'll do this one with you too then. 343 to the 1/3. 343. I didn't put the power of 1 on the other one. I apologize. I probably should put that. Just to be clear, the power is 1, the root's 4. Ooh, look at that. That's pretty. So the cubed root of 343, I don't even know that off the top of my head. I should that without my calculator. I guess I could play around with it a little bit. Is it 49 times 7? Yeah, that's what it is. It's 7, because if I think about it, 50 times 7 is 350, so 49 sevens would be 343. All right, anyway, number 2, again, it's build fluency. It shouldn't really take you that long, so it should be quick. Number 3, if you're looking for a y-intercept, remember, you should know the x value. Okay, if it's a y-intercept, you should know the x value. Think about that, and then you can just insert that x value that you should know for a y-intercept, and it's kind of like the one we did with the function in the notes. All right, so there's page 3. Page 4, it's multiple choice again. Show me some work, though. If you just circle answers, you're not going to get full credit for your homework, okay, guys? And then, again, all multiple choice. for page 7. Okay, so be sure to show work. Have fun with this. It's a new skill. I think you'll like it once you get the hang of it. It goes pretty quickly. All right. Thank you.